Millions of visitors travel to Venice every year to see a city that appears perfectly preserved. But in 2019, 85% of the city went underwater. A single night of severe flooding caused an estimated €1 billion in damage. St. Mark's Basilica, a structure that has stood for nearly 1,000 years, took on water damage that will require decades to repair. That night was a predictable, measurable surge of seawater pushing through the lagoon inlets, a tidal event known locally as Acqua Alta. Venice remains an active, fragile front line, locked in an escalating war against the Adriatic Sea. To understand why standard tides now threaten the city, you have to look at its physical elevation. Between 1930 and 1970, heavy industrial operations on the nearby mainland extracted massive amounts of groundwater. Drawing that water out caused the entire surrounding geographic region to physically sink. This graph shows a fixed high water line against a Venetian building. Over 4 decades, the ground floor dropped 23 centimeters. In a city built centimeters above the tides, that margin erased the physical buffer between a dry floorboard and a flooded one. Even though groundwater extraction was halted in the 1970s, the city never recovered the elevation it lost. Combined with modern global sea level rise, the ocean kept creeping closer to the doorsteps. This permanent sinking turned standard regular tides into existential threats. Surviving required the city to engineer an entirely new relationship with the ocean. Building a heavy stone city required solving a massive geographic flaw. Venice sits on 118 small islands. The floor beneath it is entirely soft sediment, clay, silt, and river mud, with 0 solid bedrock. To support the weight of masonry and stone, the original builders drove an estimated 10 million wooden piles vertically through the soft mud. Normally, submerged timber degrades rapidly in water, but driven deep into oxygen-free sediment, bacteria couldn't survive. Over centuries, pressure and minerals petrified the wood, turning it to stone. Every heavy stone plaza and towering cathedral rests entirely on a subterranean artificial timber forest that engineered its own bedrock. Today, that ancient foundation relies on a modern countermeasure. This is MOSE, an €8 billion infrastructure project built over 17 years, designed specifically to stop the Acqua Alta before it enters the lagoon. 78 hollow gates lie hidden on the seabed, filled with seawater, allowing ships to pass overhead. When a critical tide approaches, compressed air is pumped in, violently forcing the water out. Within 30 minutes, the buoyant gates hinge upward, physically walling off the Adriatic Sea. The city's survival now relies on mechanically overriding nature, pausing the ocean itself for hours at a time until the tide recedes. Behind these seawalls, the daily operational reality of the city requires moving everything without asphalt, trucks, or delivery vans. Every morning before 10 a.m., a rigid waterborne supply chain kicks in. Fleets of specialized flat-bottomed barges navigate the shallow canals, delivering supermarket food and construction materials directly to ground-floor water doors. Emergency services run on the exact same logic. Fire and ambulance crews rely entirely on high-speed water transit and specialized craft built to navigate narrow passages, replacing standard road protocols entirely. This highly specialized, operationally rigid logistics network replaces every modern supply chain to keep the city functioning. There is another operational reality hiding below the surface. Venice lacks a conventional sewage treatment network. Excavating heavy modern pipes directly around millions of fragile wooden piles would be structurally catastrophic. Instead, the city relies on the twice-daily tidal flush to carry waste into the open sea. This permanent contact with seawater introduces a relentless, invisible chemical threat that destroys the architecture from the inside out: salt spalling. As tidal moisture seeps into the porous brickwork and evaporates, it leaves behind expanding salt crystals. These crystals physically blow out the masonry from within. Water acts as an omnipresent chemical enemy, actively eating the city's structural bones. Fighting this continuous decay requires a massive maintenance operation. Systematically, the city has to drain the roughly 200 canals crisscrossing the historic center. temporary cofferdams are erected at each end of a canal. Once the water is pumped out, workers step in to manually remove decades of accumulated mud and debris from the floor. This dry window is the only time engineers can safely inspect and reinforce the adjacent building foundations, coordinating all of their work around narrow tidal schedules. This process never truly finishes. It is a grueling 20-year repeating cycle, constantly struggling to outpace the accumulating sediment and decay. Venice operates as an operationally exhaustive machine, a millennium-long survival project that exists only because the people underneath it never stop fighting.